Did you know that from over 500,000 tons of potatoes each year, humans create more than 3 billion cans of Pringles enjoyed around the world? And yet, they remain completely different from Lay's. This single fact opens a window into a hidden world of industrial artistry. A world where our favorite snacks are not merely cooked, but meticulously engineered. From the curve of a chip to the swirl of ice cream, the processes behind these global icons are masterpieces of technology, chemistry, and agricultural science. We often grab a can, a cone, or a bag without a second thought. But behind that simple pleasure lies a journey of immense scale and precision. It's a story that begins in the soil and ends with a satisfying crunch. A story of how raw nature is transformed into a consistent, beloved, and globally recognized product. Join us as we pull back the curtain on the incredible factories and fascinating processes that bring our most cherished treats to life. Pringles was born not from a recipe, but from a problem. In the mid-20th century, traditional potato chips were a source of common frustration. They were often too oily, frustratingly fragile, and sold in bags that seemed to be mostly full of air. In response, Procter & Gamble tasked a food scientist and chemist named Frederick Bauer with a revolutionary mission: to create the perfect potato chip. What he and his successors engineered was less a snack and more a symbol of industrial precision. The journey begins in the vast potato fields of places like Idaho, where the cool climate, high elevation, and fertile alluvial soil create the ideal conditions for growing the perfect tuber. The potatoes destined for Pringles are chosen for their high dry starch content, which gives them a firm texture and the ability to be transformed into a fine, consistent powder. As autumn arrives, massive potato diggers roll across the fields. Guided by underground sensors, dual steel blades cut deep into the soil, gently lifting entire rows of potatoes to the surface. A vibrating screen mechanism then kicks in, its thousands of subtle tremors shaking loose the soil, roots, and pebbles without bruising the potatoes' delicate skins. Specialized harvesters follow, their hydraulic arms gathering the unearthed potatoes and feeding them onto a conveyor that gives them a final shake before transferring them into 25-ton transport trucks. Once at the factory, the potatoes are unloaded into a recirculating whirlpool washing system. High-pressure water jets and moving chain conveyors create a powerful current that tumbles the potatoes against each other, scrubbing away every speck of dirt. After multiple rinses, they enter a rotary drum washer, a 5-meter-long stainless steel cylinder where hundreds more jets ensure they emerge spotless, ready for the next stage. Here, the Pringles process diverges dramatically from traditional chip making. The potatoes pass through an abrasive drum peeler lined with a sandpaper-like material, which strips away the outer skin, leaving only the smooth, golden flesh. After a brief blanching in hot water to soften them, they are fed into a high-speed cutting chamber. Spinning at 1,200 revolutions per minute, razor-sharp blades slice and chop the potatoes into small, uniform cubes. These pieces are then cooked in a pressurized steam chamber, where the high temperature gelatinizes the starch, cooking the core evenly while making the outer layer smooth and elastic. Immediately after cooking, the softened potatoes are mashed into a smooth paste and filtered to remove any fibrous residue. This fine mash is spread over large, heated, rotating drums. The heat rapidly evaporates the moisture, transforming the paste into thin, crispy sheets that crack and break into dry flakes. These flakes are milled into a fine potato powder, the fundamental building block of a Pringle. This powder is the key to Pringle's unmistakable identity. In a colossal industrial mixer, the dehydrated potato flakes, which make up only 42% of the final product, are blended with water, cornstarch, rice flour, wheat starch, and a precisely measured mix of emulsifiers and salt. This creates a soft, elastic, semi-moist dough. This dough is then transferred to a continuous rolling conveyor, where a massive steel roller compresses it into an ultra-thin sheet, just 1 millimeter thick. The sheet of dough passes through a rotary cutter, which continuously stamps out neat, oval shapes. The excess dough is vacuumed back into the system to be recycled. Now comes the most crucial stage. The oval slices are transferred onto a specially designed mold that guides them into the hot frying oil. As they fry for just 11 seconds, the mold holds the edges in place while the center puffs up, creating the iconic hyperbolic paraboloid, or saddle, shape. This mathematical design is ingenious. It allows the chips to stack perfectly, distributes pressure evenly to prevent breakage, and delivers a flawless, satisfying crunch. After emerging from the fryer, the crisps are blasted with hot air to remove excess oil. They then pass through a flavoring chamber, where a fine mist of seasoning powder coats every surface. With over 160 distinct flavors worldwide, from Japan's spicy wasabi to America's rich cheddar cheese, each Pringle becomes a tiny vessel of global culture. Finally, at the end of the line, the perfectly curved slices stack themselves in flawless order on the conveyor. A mechanical system compresses them into a column, wraps them, seals the metal bottom, and caps the plastic lid. From a humble potato in an Idaho field to a perfect, stackable crisp in a can, the Pringles journey is a testament to the power of food engineering. Few people know that ice cream was once a luxurious privilege reserved for the elite. In ancient Rome, Emperor Nero would send servants to the mountains to gather snow, which was then mixed with honey and fruit to create one of history's first frozen desserts. For centuries, this sweet treat remained an indulgence for royalty. It wasn't until the advent of refrigeration technology that it slowly melted into everyday life, becoming a beloved symbol of joy for all. The modern ice cream journey begins not on a snowy mountain, but on the lush dairy farms of places like Wisconsin, the dairyland of America. Here, the quality of the final product is determined by the health and well-being of the cows. They are given a carefully balanced diet and proper exercise to ensure stable productivity. Once a newborn calf arrives, the mother cow begins producing an abundant flow of nutrient-rich milk, the very foundation of delicious ice cream. In automated milking stations, advanced technology manages every step. Each cow is identified by an ear tag chip that records her yield, milking time, and health status. The fresh milk, averaging 25 to 30 liters per cow per day, is transferred through closed stainless steel pipelines directly into cooling tanks maintained at 4 degrees Celsius. This immediate chilling is critical for preserving freshness and vital probiotics. Within hours, giant tanker trucks, true mobile refrigerators, transport the fresh milk to the ice cream factory. Upon arrival, the milk undergoes rigorous quality control. Samples are tested for freshness, fat content, and, most importantly, antibiotic residues. If even a trace amount above the safety threshold is detected, the entire truckload of tens of thousands of liters is rejected. Once approved, the pure milk is pumped into massive mixing tanks. Here, it is blended with cream, sugar, milk powder, stabilizers, and emulsifiers, all measured with gram-level precision. The mixture is heated to 40 to 50 degrees Celsius to dissolve the sugar and disperse the fat evenly, creating a uniform base. This blend is then pasteurized, heated to around 85 degrees Celsius to destroy harmful bacteria and deactivate spoilage enzymes, ensuring the product is safe while preserving its flavor. The next stage is homogenization. The milk base is forced through a fine filter at high pressure, breaking down the fat globules into smaller particles. This prevents the cream from separating and gives the final ice cream its signature silky smooth texture. The base is then aged for several hours to allow the ingredients to fully bind together before it enters the freezer. Inside a continuous freezer, the mixture is chilled and churned while air is whipped into it. This process, known as overrun, is what gives ice cream its light, airy texture. The amount of air incorporated determines the density and quality of the final product. From here, the semi-frozen ice cream is ready to be shaped. For classic ice cream bars, automated nozzles pump the mixture into hundreds of precisely engineered metal molds moving along a conveyor. Robotic arms insert the wooden sticks with millimeter accuracy before the molds enter a flash freezing tunnel where temperatures plummet, solidifying the bars almost instantly. Once frozen, a mechanical system gently releases the bars, which are then guided through dipping baths of melted chocolate or spray nozzles that coat them with crunchy nuts and cookie crumbs. For cones and cups, the process is different. Empty containers move along the conveyor, and multi-nozzle pumps fill them with perfectly swirled layers of ice cream. Toppings like strawberry sauce or chocolate fudge are added before lids are automatically sealed. For the iconic ice cream cone, a machine spirals the ice cream flawlessly from the center to the edge before it's crowned with a topping. Every type of ice cream has its own dedicated production line, moving at incredible speeds. A single line can fill up to 20,000 molds per hour. Finally, the packaged products are transferred into deep freeze storage rooms kept at a stable -25 degrees Celsius. In this intensely cold environment, the ice cream fully hardens and maintains its structure and flavor until it begins its journey to supermarkets, stores, and the hands of eager consumers around the world. The story of chocolate is a journey of magical transformation, where a bitter, humble bean is nurtured into the legendary sweetness that has captivated the world for centuries. That journey begins in the hot, humid climates of countries like Côte d'Ivoire, Ghana, and Ecuador, where the cacao tree thrives. This unique tree produces pods that grow directly from its trunk and branches, and its survival depends on a silent, tiny partner, a biting midge, no bigger than a few millimeters, which is solely responsible for pollinating the tree's small, delicate flowers. Without these flies, global cacao yields could plummet by up to 90%. The main cacao harvest runs from October to March. Despite being the ingredient behind world-famous chocolate bars, cacao is still harvested entirely by hand. Farmers use machetes or curved knives on long poles to carefully cut the ripe, golden red pods from the tree. Each cut must be precise, as a wrong move could damage the stem and prevent future fruiting. After harvesting, the pods are split open to reveal the treasure inside. Plump cacao beans wrapped in a sticky, sweet tart white pulp. This pulp is crucial for the next stage, fermentation. The beans and pulp are collected in wooden boxes or piled under banana leaves for 5 to 7 days. During this time, microorganisms in the pulp trigger a cascade of chemical changes, raising the temperature to around 50 degrees Celsius. This process is the genesis of chocolate's complex flavor, breaking down the bitterness and developing the rich, fruity, and floral notes. The beans must be turned daily to ensure even fermentation and prevent mold. Once fermentation is complete, the beans are spread out on large mats to dry in the tropical sun for about a week. This reduces their moisture content and further develops their flavor. The dried beans are then packed into jute bags and shipped to chocolate factories around the world. Upon arrival at a factory like Hershey's, the air is thick with the rich aroma of roasting cacao. The beans are roasted at temperatures up to 150 degrees Celsius, a critical step that unlocks their signature flavor and removes any remaining bitterness. After roasting, the beans are cracked and their outer shells are separated from the inner nibs through a process called winnowing. These nibs are the concentrated essence of cacao. The nibs are then finely ground in mills, creating a thick, dark liquid known as cocoa liquor. A portion of this liquor is put into a powerful hydraulic press to extract cocoa butter, the prized, pale yellow fat that gives chocolate its melt-in-your-mouth quality. The remaining solid is cocoa powder. To create milk chocolate, the cocoa liquor and cocoa butter are blended with sugar, milk, and other ingredients according to a secret recipe. This mixture is passed through a series of heavy rollers that grind the particles down until they are imperceptibly fine, creating a smooth, dense paste. This paste then enters a conching machine where it is heated and stirred continuously for hours or even days. This process further develops the flavor through the Maillard reaction and creates an exceptionally smooth texture. The final crucial step is tempering. The liquid chocolate is carefully cooled and reheated in a controlled cycle. This process aligns the crystals in the cocoa butter, resulting in a finished chocolate that is glossy, has a satisfying snap when broken, and resists whitening during storage. Now, the liquid chocolate is ready for molding. At the Hershey factory, this is where the magic of kisses begins. The name comes from the unique motion of the depositor as it drops a dollop of chocolate onto the conveyor, gently, like a kiss. For chocolate bars, the tempered liquid is poured into molds, which are then vibrated to remove air bubbles and sent through a long cooling tunnel to solidify. Once chilled, the molds are twisted, and the perfectly formed bars drop onto a conveyor, ready for their iconic wrapping before being boxed and shipped to delight chocolate lovers everywhere. Just as Pringles re-engineered the potato, another snack icon owes its existence to an unexpected twist of industrial fate. In 1940, a mishap in a popcorn factory led to the creation of strange, puffed corn sticks. They were light, airy, and incredibly crunchy. But the true stroke of genius came from Richard Montañez, a janitor at the factory, who took the plain puffs home and sprinkled them with chili powder. This act of culinary curiosity gave birth to Flamin' Hot Cheetos, a product that would not only skyrocket sales, but also propel Montañez from the factory floor to the executive ranks. The intricate journey of every Cheeto stick begins in the vast cornfields of the American Midwest.
The corn grown for Cheetos is not the sweet corn you eat on the cob. It is a specific hybrid of hard yellow corn developed for its high starch content, low moisture, and extreme density. These properties are essential for achieving the signature puff and crunch during the manufacturing process. Across the sprawling fields, giant GPS-guided tractors lead fleets of precision farming machines. Modern multi-row planters simultaneously open furrows, drop seeds, apply fertilizer, and cover the soil in a single pass. As the corn grows, massive center-pivot irrigation systems rotate like giant compasses, distributing water evenly from nearby channels, with soil moisture sensors ensuring optimal hydration. When the corn silks begin to dry and the fields turn a golden hue, it's time for harvest. High-capacity mechanical harvesters glide through the rows, cutting the stalks and drawing the entire plant into the machine. Inside, the husks are stripped away, and the high-quality ears are isolated and moved into storage bins, while the leftover plant matter is blown back onto the field as natural mulch. At the processing plant, the corn ears are fed into an automatic husking machine, and the kernels are separated from the cob. Unlike canned corn, where the kernel's shape is paramount, corn for Cheetos is valued for its internal structure. The golden kernels are thoroughly washed and then transferred to a drying chamber, where their moisture content is reduced to the perfect level for the next stage: grinding. The dried kernels are fed into an industrial milling system, where high-speed steel rollers crush them into a coarse powder known as cornmeal.
Now, the true transformation begins. The cornmeal flows into automatic weighing hoppers, where its moisture content is carefully increased from 10% to about 15 to 20% by adding water. The moistened meal is fed into the heart of the Cheetos operation, the extruder. The extruder is a machine that cooks and shapes the cornmeal using intense heat and pressure. The mixture is heated to around 138 degrees Celsius, 280 degrees Fahrenheit, and a large internal screw generates immense friction, turning the cornmeal into a thick, pliable dough. This dough is forced under high pressure, up to 300 psi, through a shaping die. The moment the pressurized dough hits the open air, the sudden drop in pressure causes the moisture inside to flash into steam, instantly puffing the dough into the familiar, irregular shape of a Cheeto. This extrusion process doesn't just shape the product, it fundamentally alters the corn's structure, creating its light, airy, and crispy texture. The freshly puffed pieces are then sent into a massive oven, where they are baked for about 4 minutes to reduce their moisture content further and achieve that iconic, crispy texture. Finally, the unseasoned puffs enter a rotating flavor drum. Here, a heated blend of rice oil and real aged cheddar cheese powder is sprayed onto the tumbling snacks. As they travel through the 25-foot-long chamber, each piece is coated evenly in that bold, signature Cheetos cheese flavor. From there, the finished Cheetos are sent through an automated packaging system, where they are weighed, sorted, and sealed into bags. From an accidental factory mishap to a globally recognized snack, the story of Cheetos is a perfect example of how innovation, science, and a dash of daring flavor can create a cultural phenomenon.